Hello everyone. Today we want to discuss about optimization of service process at Church's Chicken. Myself Sivakrishnam Raju, Ajay Karnam, Kura Krishna Chaitanya had did this project. We want to discuss initially about introduction and then objectives, continuing with model description, animation, result, and finally conclusion. We consider Church's Chicken in Orange, Texas for analyzing and simulating. There will be 8 resources in the store, in which 4 will serve dine-in customers, 2 will serve drive-thru customers, and 2 cooks who will be serving dine-in and drive-thru customers. There are 2 types of entities who are dine-in and drive-thru customers. During weekends, arrival rate of customers will be more, so thereby there is a chance of increasing the queue and wait time of the customers. So in this project we want to reduce this. So our objectives are to collect the arrival times of customers and time taken to serve them, and to reduce the wait time of customers in queue, and to increase the profit of the restaurant. The arrival of dine-in and drive-thru customers follow non-Poisson arrival distribution. We had collected the data and input it in input analyzer. We got the results as follows: triangle distribution for drive-thru customers, this triangle distribution for dine-in and for food preparation of drive-thru, and this one for food preparation of dine-in customers. And this was the flow process in the store. Dine-in customer enters the queue, orders the food, and wait until the food was reached to him, and then he finally leaves the store. In the case of drive-thru customer enters the queue. If the queue is more than 4, then the customers will be leaving the store. If the queue is less than 4, then he will be waiting and ordering the food, and waits until the food was reached to him, and finally he leaves the store. Next will be continued by Ajay Karnam.
Hi, I would like to discuss about the model of a project. And this is the model of a project. Here in a project we have 2 types of customers. One is the dine-in customers and the other is the drive-thru customers. First let's talk about the dine-in customers. The dine-in customers arrive through this create module, and in this assign module the arrival time of the dine-in customers is assigned. And the arrival here the time at which the dine-in customer arrive is noted down. And then at this end, and then there are 10 customers entered through this entrance station, and with the help of this route module they are transferred to the DI ordering station. Here they order the food, and then they are transferred to the food preparation station, and in this process the food is being cooked, and they wait for the food, and after the food is prepared, through this route they exit the system, and here is the dispose of DI customers. In this record module is used to record the time spent by each dine-in customer in the queue in the system. Coming to the drive-thru customers, this assign module is pretty much similar to that of dine-in customer assign module. And in this entrance station the drive-thru customers enter the system, and through this route they transfer to the order receiving station. Here comes the important part, the decide module. If the queue length is more than 4, the customer exits the system without ordering the food. If the queue length is less than 4, the customer orders the food, then waits for the food to be prepared. Then with the help of this route module, the customers are transferred to the DI order delivery station, and this delay module is to show the time for which the customers take 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 the delivery of the prepared food and pay the bill. And the store and unstore modules are for animation purpose. And with the help of this route module, they go to the DT exit station and then they are disposed from the system. Model description. We have 2 create modules, 4 assign modules, 8 stations, 5 routes, a decide module, a storage module, delay module, unstore, 3 record modules and 3 dispose modules. This is the animation of a project. Here we have resources, 4 resources, and they are taking shifts. So two resources in the morning and 2 resources in the evening, and these resources are for the dine-in customers. Here these resources are for the drive-through customers, and this is the kitchen where there are 2 cooks, but it might not be evident in the picture. There are 2 cooks in this kitchen, and this is the dine-in customer, and this is the drive-through customer, and this is the route from the entrance station of the dine-in customer to the order receiving station, then from order receiving station to the food preparation station, then from the food preparation station to the exit station. Now the dine-in customer arrives, he goes through this along this route, order the food, then wait for food here at this station, and after the food is delivered he exits the system. For animation purpose, we have assigned the route transfer time as 30 seconds for the dine-in customers and 10 seconds for the drive-through customers. Now coming to the drive-through customers, again there is a system which is not very clear in this picture. In this system, the drive-through customer orders the food, and these resources take the delivery, take the order, then they prepare the food. The cooks prepare the food. In the meantime, the drive-through customers come to this station where they wait for the food and pay the bill, and then they exit the system through this route. Again, we have assigned 10 seconds so for the animation purpose. Now the next part is results, which will be explained by my friend.
Hello everyone, we have reached the most crucial part of our project. Those are the results. We ran the model and the Celestial model for 50 replications. We compared the crystal reports of both the models, and we had achieved our objective of reducing number of lost customers, but the profit is reduced instead of increasing. The Celestial number of resources were found out using OptQuest. The OptQuest to find suggested number of resources is here. We thought of increasing 2 chefs and one drive-through employee for taking the drive-through customers, and because of that the objective value is decreased to 747. And comparing both the actual model and Celestial model, what we found that is the number of lost customers is decreased from 1.64 to 0.78. It's a good decrease, but the profits are also reduced from 1022 to 790. But this is a very bad sign in a business. And our conclusion from these results are that increasing the order receiving employee for drive-through customers will decrease the queue length, but because of this the profits will be decreased. This occurred because the cost of hiring new employees is greater than the loss due to lost customers. This solution is helpful, but when the customer number increases. Thank you.